This video is about the logistic regression by the Jane mode. So this is exactly the one I used, the proc I used in the first video, right? So this is for logistic regression. So there are a bunch of procedures or procs that you can use for logistic regression. So the first one is of course the it's called logistic, proc logistic. But why we are not going to use that? So we're going to talk about the reasons in the following part. So anyway, so we're going to use this one. And to use this for logistic regression analysis, you're going to state the data set. And this descent is to ask the SAS program to sort the result, that the result high opiate use, uh, to sort the result by the descending order. So the one will come first, the zero will come later. So the ones come later, the zeros will be used as the reference, right? So that's why we're going to use the same here. And in the class, then the class is to tell that, oh, okay, so for this cancer status, it is a categorical result, right? The categorical result. And for this one, we're going to have a reference, uh, 0 as the reference group. So for those that does not have cancer, we're going to use that as a reference group. And then there is an option to say that we should uh, model that based on this using a parametric approach and use this reference groups, right? So there are other options. If you're interested, you can search for the SAS help files to know more about this um, this things. But basically, that's what you need to know in this analysis. And then we're gonna have model. And a model is very simple. We're going to say this is the outcome, high opiate use where 1 or 0. And then we're going to have the age and we're going to have the cancer, these two variables inside, right? And then we're going to specify the distribution is a binomial, which is the 1 and 0. It's a logistic regression model, right? And we have the link as logic. This is how we define that it's a logistic regression. Actually, JML can also be used for Poisson distribution, Poisson models. If you learn the statistics 2 courses, level 2 courses, you will know these distributions. And if by the chance you are also using SAS, you will know how to do it. But otherwise, you can search for the help files. Actually, there's a lot of options, a lot of choices there. Okay, so this one is to estimate, is to say that I want to have an odds ratio, and please estimate the odds ratio for me, which is cancer yes versus no. All right, so this is the results we want to have. So basically, we're saying that in this model, we're going to control that by age, and we want to know that the high use of opiate or the low use of opiate, does that matter uh, in terms of the cancer status? All right, so this is the result. We're going to have the result by age, and cancer we have this estimates, which is a beta, right? So, but this is not an odds ratio. If you want to have the odds ratio, you have to have the exponential of this value, right? So, so according to the statement, we will have this odds ratio here. So the beta is here is the same, right? So this is produced by the statement here of this estimate one, right? So um, well, so in this report, in those results page, you can see a lot of tables. These are called ODS tables. So these tables are very informative. So you will know a lot of information there. For example, it tells you the ordered values of your outcome. As what we have specified here, we say it should be in descending order. Um, and that is why that you're going to see a 1 comes first and 0 comes second. And, and it's going to tell you that it is modeling the probability that this high opiate use of 1, right? So 0 is the reference. And you can also see the class levels. For example, for this cancer status, there are two groups. One is 1, the other is 0, right? And then later in the report, you will see that for cancer, it is reporting the value of 1, right? So 0 is the reference group. So the odds ratio here is 1 versus 0. And because 0 is the reference group, so it is omitted. So you're only going to see the 1 here. And that is corresponding to this estimate. In the statement, you're going to say, I want to have the odds ratio of cancer 1, and you can save the 0 here because 0 is the reference group. Okay. So um, in this jam mode and also in logistic regression, you got to pay attention to these options like this descending, this in the class. If you get a chance to specify the reference, for some of the procs like proc you cannot set the reference here. You have to manipulate the orders. All right, so if you're interested, we can talk about that later. But in this one, I just want to let you know that all of these options matters. So if you change, for example, you are not going to use the, like if you don't have this option here, you might have a different result, right? So it has a different meaning here. And also the distributes, this links, and also this specification of this groups. Uh, this, this one all of these settings matters. So you're going to pay attention to that. And online, in the references I provided earlier, you can see a lot of examples on how to set these values. So this will be the basic logistical model. But you can see that here I commented some lines like this repeated line. Uh, and now I'm going to come to the point to say why we have to use this JMode. Because JMode allowed us to check the results using the method called the generalized, which is called the generalized estimating equations, GEE models. So these are the GE models. So basically, the GE models is going to help us uh, to partition the effort or the bias caused by the repeating measure of something. So in our case, one patient might have multiple hospitalizations, right? So it could have bias because that patient has been repeatedly admitted into the hospital, and that patient is going to have a tendency either uh, as a high opiate user or as a lower opiate user. So both ways it is going to bias the result. So that's why we have to adjust for the spiles, and that's why we need to use that GE models. And to use the GE models, we're going to use this proc gem mod, and we're going to have one more statement here. We're going to say, so actually in our data, so the data is repeated by this key HSN, which is the patient. Okay, so with that, because now we have the repeated term, then we need to specify the type of this. This is called a working matrix. So I'm not going to go into the details of that, but that part is very interesting. If you guys are interested, we can talk about that in other time. Basically, it is going to decide a matrix or a pattern to that is going to be the best way to estimate those 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 patterns within the same patient. Right. So, but anyway, so it's we have to talk about that in other time if you are interested in that. And then this statement is gonna tell the SAS to the first is that you should give us a result without the so without adjusting the repeated effects, so that we can compare with the two. So without adjusting the result, the repeating effect, how the results are gonna look like, and then we're gonna have an adjusted one. But for the adjusted one, you don't have an option because it is by default it's gonna print. It is gonna be provided. So the next is that we need to print this model-based or the unadjusted results in the result area. So if you don't have that, you don't have this risk. These two should come together. And then of course we're gonna have those covariate, tables, and because some other people are super good at that, they're gonna use these tables and they're gonna make calculations by themselves, and that's why we sometimes we need these reports. But anyway, so run this data, you're going to have more results in the what's so-called ODS table. So the beginning part will be similar. We have the result is based on the probability of high opiate use as 1, and then you're gonna see that these are the results. These are the betas estimates, right? So for this cancer, we have this estimate, this beta, and if we have an exponential of that, we'll have the odds ratio. So you will see, okay, so this one is called empirical, which is adjusted by the repeating the potential bias by repeating measures, right? So this is called the model-based, which is not adjusted by that. Well, so you will see that actually the result in terms of the point estimate, it is exactly the same, right? It's just that if you look at the standard error, it will be different. So for the empirical, which is adjusted for the repeated effect. So the standard error will be different, and because the standard error is different, and then the confidence interval will be different. So that's the real difference here. So the GE models won't change the point of estimate, but it's going to tell you a different confidence interval, and that is the key for this analysis. All right, so remember that for logistic regression models, there's a lot of things to check. For example, multi-collinearity, outliers, fitness of models, best working covariance structures, and export results. There's a lot of things to think about. But I'm gonna stop here because I trust that all of this will be covered or has already been covered in your statistic courses. So I'm not gonna talk about that. Okay, so basically uh, this is the last video I'm gonna make for this statistic analysis. So now I think it is pretty much the things I want to talk about using SAS to make analysis for uh, the for a given project. So so I hope that in this video I've covered the basics, and if you guys have more questions, just send me email, and I'm happy to discuss.